Assalamu alaikum. Today we will start one more topic, that is differentiation of some implicit functions. These questions are asked in exercise 5.3 of NCERT book. Let's start from question number 1, that is find dy by dx of this function. Now, what do you mean by first? Actually, I have written here it is implicit function differentiation. So first of all, we need to understand what is an implicit function and what is an explicit function. Suppose we have a function f of, say, x and y equal to 0. If we can write this equation, if we can extract this dependent variable explicitly, like we can write y is function of any other g of x, then this relation is said to be explicit, right? Similarly, if we cannot separate x and y from this equation, if we cannot separate x of y from this equation, that is, we cannot write y is equal to some another function of x, if we cannot write it like this one, so it is said to be implicit function. However, this question number 1, it can be written as implicit function. It is an implicit function, but it can also be written as an explicit function. We can explicitly write y in terms of x, right? Transfer, so we can write it like 3y is equal to sine of x minus 2y, and then differentiate. But we can't, but we can differentiate it like that way also, but let's go straightly. Now, what we do in implicit functions, we directly differentiate this whole equation on both sides. Like on the left hand side, we differentiate this term, and on the right hand side, we differentiate this term, right? Now, as already mentioned, differentiating both sides with respect to x. So I am actually differentiating with respect to x. It means that I am actually differentiating like d by dx, right? Now see here. Now it means that we know the differentiation goes term by term. That is, the differentiation will first occur to this term, then addition will remain same, then it will occur to this term is equal to the differentiation to this term. See, d by dx of 2x, d by dx of 3y, and d by dx of sine x. At this setup, I am just applying differentiation, but I have not executed the operation of differentiation, right? Now here, at this setup, I will use the linear property of differentiation. That is, 2 will come outside of differentiation. The differentiation will apply to its variable, that is x. That's dx by dx, 2 will come out, right? Similarly, 3 will come out and differentiation will apply to y. So this would be dy by d of x, right? Now, already mentioned, already discussed this differentiation of sine x is always cos of x, right? Now, this is differentiation of x with respect to x. This has also been discussed. This is always 1. So this is 1 into 2, that's 2, right? Now this is 3. Now this is dy by dx, and this is cos of x. Now look at the question. I'm supposed to calculate dy by d of x. So simply from this equation, put dy by d of x on one side of equality and transfer all the terms related to the other side. See, 3 dy by dx is equal to cos of x minus 2, right? I have transferred 2 to the side. Then transfer this 3 to the other side, it will come in the denominator, right? So I have calculated dy by d of x, right? Similarly, we have one more question of this exercise, that is question number 8, I think. Okay. Similarly, we know we have written here, the question is sine square x plus cos square y is equal to 1. So it's not like, don't get confused. It's like cos square theta plus sine square theta is equal to 1. Here theta was same, but here different. X is different, y is different, right? So it's not that formula actually. So differentiating this both sides with respect to x, it means that I have to go term by term. That is, first the differentiation will apply to this, then term by term differentiation will apply to this term, and then finally to 1. And you know the differentiation of constant, that is 1, is 0. It means that this term is actually 0, right? But here, while differentiating, I will use the chain rule. Chain rule, see here, it is sine square of x. If we look at sine square of x, this sine square of x is actually sine x raised to power 2. This is whole raised power 2. It means that it is of the form x raised power n. So chain rule says that first you have to differentiate the exponent. See, first I have to differentiate this term, then this term, and then this term. Now this setup, for this I have to go for the exponent, that's 2. 2 will come, the differentiation of x raised power n comes to the front side, and then x raised power n minus 1. It's like same thing. So 2 will come in the front. Here power of sine of x was 2, so it will be reduced by 1. That is sine of x right here. Now then differentiation of the original function, that is sine of x, right? This is chain rule actually I am applying. Similarly, first the differentiation will be applied to the exponent, that's square. It is of this form x raised power n. The differentiation would be n would come in the front. X raised power, it's 1 degree less. So it means that 2 will come front, then cos of x, that is same, but its degree would be reduced by 1, right? Now then the differentiation of cos of y, right, is equal to, the differentiation of constant is 0. Now it is same twice sine x. Now here I have applied differentiation of sine of x. So this is cos of x. Now here this is 2, this is cos of y, 2, this is cos of y. Differentiation of cos of y. First you need, again I will apply here chain rule. See here how. First the differentiation would apply to cos, that is minus sine of y. But it is not, it is differentiation with respect to x, but here the argument is y. So I need to differentiation, then into the differentiation of dy by dx by chain rule, right? So this is 0. Okay, minus would come in the front, and I am actually here applying the formula twice sine theta into cos theta is always equal to sine 2 theta. Here is also twice sine theta cos theta, minus will come in the front, so that is sine of 2 theta, but here theta is y, and in this case theta is x. So this is sine of 2x, and this is sine of 2y into dy by dx, that is there, is equal to 0. From this equation, transfer this to this side and put dy by dx only in one side. That's dy by d of x is equal to 2x divided by sine of 2y. That we were supposed to calculate dy by d of x. Now let's move to one more question, that's question number 10 of this exercise. That is about y is given as tan inverse of 3x minus x cubed divided by 1 minus 3x square. So we have actually various questions of this type. The best method of these questions is actually the substitution, because the interior, the argument of these inverse functions is becoming simpler by substitution methods. I am putting actually x equal to tan theta. So here it would be 3. So if x is tan theta, it means that theta is actually tan inverse of x. Actually I am applying, it is like this one. Let me tell you, x, I am putting tan of theta inverse, apply tan inverse to both sides. Tan inverse of x is equal to tan inverse of tan of theta. Tan inverse, that is identity. So this is theta. So theta is actually tan inverse of x. That is what I am written it. Now this is y is equal to tan inverse of, that is already there. Now 3 tan theta, because I have put x equal to tan theta, minus tan cube theta, 1 minus 3 tan square theta. Now this argument of tan inverse, this is actually the becoming the formula. This is actually tan of 3 theta. That is why they become simpler. These reduce it to some formulas, right? Now tan and tan inverse, they are inverse functions, so remaining would be only 3 theta, right? Now this is 3, and theta, theta is tan inverse of x, right? Now so actually we have simplified this whole thing. Y equal to tan inverse of this, we have actually simplified it to y equal to 3 tan inverse of x. Now differentiate. Now differentiate both sides with respect to x, because this is now function of x, right? So dy by d of x, for this 3 will be there, and differentiation of tan inverse of x. We have already discussed differentiation of tan inverse of x is 1 divided by 1 plus x square. So the answer would be 3 divided by 1 plus x square, right? One more question of the same pattern is question number 15 of this exercise. That is question, that is sec inverse of 1 divided by 2x square minus 1. Same, this is inverse trigonometric function. The argument would become formula by some substitution. So better substitution is x equal to cos of theta. So obviously theta would be cos inverse of x, right? Now substitute x equal to cos theta here. So this is 1 divided by twice cos square theta minus 1. But twice cos square theta minus 1 here, it is becoming actually formula. This is cos of 2 theta, right? And 1 divided by cos is sec theta. You know, here I have written sec is there, sec inverse is there. 1 divided by cos of 2 theta would be sec of 2 theta, right? The one reciprocal of cos is actually sec, right? Now sec and sec inverse and sec, they are identical. This their operation is identical because they are inverse functions. So we are remaining with 2 theta. Now this is 2, and we know theta is cos inverse x. Similar method. Now we have reduced the original equation to the simpler form, y equal to twice cos inverse of x. Now we will like to use the differentiation. Now what differentiation to both sides? Now what does this what this means? Now differentiating to both sides, dy by d of x, dy by d of x is equal to, 2 is there, differentiation of cos inverse of x. Now 2 is already there. Now differentiation of cos inverse x is minus 1 divided by under root of 1 minus x square. Now 2 into minus 1 is minus 2 divided by under root of 1 minus x square. So this is the total differentiation of this, right? So let's set off here today. Let's stop today.